SpaceX is an aerospace company. It was founded by Elon Musk. His vision is bold. He wants humanity to live on multiple planets. This goal drives SpaceX. Mars is the primary target. Such a future would change our species. It ensures our long-term survival. This is a grand ambition. Starship is the vehicle for this vision. It is an enormous rocket. It stands taller than any before it. Its purpose is to carry people and cargo. It will travel to Earth orbit. It will go to the moon. Ultimately, it will journey to Mars. A key feature is its full reusability. This is crucial for future space travel. The significance of Starship cannot be overstated. It is the cornerstone of deep space exploration plans. SpaceX aims to drastically lower launch costs. This reduction could make space far more accessible. It might open up a new era, an era of widespread space activity and discovery. Starship is more than just a rocket, it is a new paradigm. The latest test launch was highly anticipated. People around the world watched. It was one flight in a series of tests. Each launch provides invaluable data. Engineers learn from every flight. Successes and failures both teach lessons. The ultimate goal is constant improvement. The path to Mars is paved with such tests. This recent flight was another step. Launch day always has a unique atmosphere. Tension mixes with great excitement. Engineers are at their stations. They monitor thousands of data points. The final countdown begins its slow march. Every second holds immense weight. Years of work lead to these moments. The team watches, focused and ready. Then comes liftoff. The powerful Raptor engines ignite. They create a colossal plume of smoke and fire. The massive rocket begins its slow ascent. The ground trembles with the raw power unleashed. It is a breathtaking spectacle of human ingenuity, a testament to what we can achieve. This is engineering at its most dramatic. The rocket climbs, defying gravity. During the initial phase, Starship soared upwards. It pushed through Earth's dense atmosphere. Onboard systems appeared to function as planned. The vehicle steadily gained speed and altitude. Millions watched, live streams carrying the images globally. Hope was high for a successful test flight. Each milestone was a small victory. The team looked for positive signs. This specific flight had its own objectives. SpaceX aimed to test certain systems. Perhaps new maneuvers were planned. They always try to push the vehicle's limits. This is how progress is made. Each Starship flight builds on the last. The goals might include reaching a certain altitude, or testing separation of the stages. Data on performance is key. The mission progressed for several minutes, then the situation changed unexpectedly. Telemetry data streamed back to mission control. This data is the lifeblood of any test flight. Engineers watched their screens with intense focus. Suddenly, an anomaly was reported. Something was not right with the vehicle. The mood shifted quickly. The dreaded words "contact lost" were heard. This means communication with Starship ceased. No more data flowed from the rocket. It was flying without ground control. Or perhaps it was no longer flying. This is a critical failure point in any mission. The team on the ground faced uncertainty. The vehicle's status was unknown. Soon, visual evidence emerged. Reports indicated the rocket broke apart. Long-range cameras captured the event. The flight test had ended. It was an abrupt and unfortunate conclusion. The vehicle did not complete its planned trajectory. This was not the outcome anyone hoped for. Yet, it is a known risk in rocket development. In the immediate aftermath, efforts focused on understanding. SpaceX confirmed the loss of the vehicle. Sometimes a range safety system is activated. This destroys the rocket if it veers off course. Other times the vehicle succumbs to aerodynamic stresses, or an internal failure causes a breakup. Safety for people on the ground is always paramount. Investigation would begin swiftly. Section 4. SpaceX Responds, the iterative path to success. SpaceX quickly issued official statements. They acknowledged the mission anomaly. The company highlighted the data gathered before the failure. This approach is typical for SpaceX. They are often transparent about their tests. The focus shifted to the positives. What did they learn this time? That is always the question. Elon Musk also shared his thoughts. He often uses social media for this. His perspective on failures is well known. He sometimes calls them rapid, unscheduled disassemblies. This term reflects a philosophy. Failures are learning opportunities. His optimism for the program usually remains strong. He encourages the team to press on. This resilience is a hallmark of SpaceX. This response reflects the core SpaceX philosophy. They build, they fly, they test. Sometimes they fail. then they fix the problems, and they repeat the cycle. This iterative process allows for very rapid development. Mistakes are not just tolerated, they are expected. They are treated as valuable lessons. This accelerates learning. Even in a flight that ends prematurely, much is learned. The sensors on Starship collect vast amounts of data. Engineers will meticulously analyze every piece of information. This data will reveal what went wrong. It points to areas needing improvement. This information is crucial. It directly feeds into the design of the next Starship. The next one will be stronger. Section 5. The technical hurdles. Building a Mars rocket. Starship is an incredibly complex machine. It is the largest and most powerful rocket ever conceived. Many new and unproven technologies are involved. The Raptor engines themselves are revolutionary. They use a full-flow staged combustion cycle. SpaceX is truly pushing the boundaries of engineering. This ambition comes with immense challenges. Engine performance and reliability are critical. Starship's Super Heavy booster uses over 30 Raptor engines. The Starship upper stage uses several more. All these engines must work in perfect harmony. Achieving this level of consistency is a major hurdle. The failure of even one engine at a critical moment can be catastrophic. This complexity demands rigorous testing. Structural integrity is another massive challenge. The forces during launch are tremendous. The vehicle must withstand incredible stresses. Atmospheric re-entry, when it happens, is even tougher. The heat shield technology must protect the ship. Starship needs to survive extreme temperatures and pressures. Building a robust structure of this scale is hard. The planned launch and catch system is also groundbreaking. Mechazilla, the launch tower, aims to catch the booster. It may also catch the Starship itself. This has never been attempted before. It is essential for achieving rapid reusability. This reusability is key to lowering costs. Perfecting this system is a huge technical undertaking. Each part of Starship presents new difficulties. Section 6. The Mars Dream still burning bright? SpaceX's ultimate goal is Mars. Elon Musk envisions a self-sustaining city there. This would make human life multiplanetary. Starship is the cornerstone of this vision. How does this recent flight anomaly affect these Mars plans? Setbacks are expected in bold endeavors. The ultimate goal likely remains unchanged. The dream of Mars continues to burn brightly at SpaceX. Section 7. Future trajectories, learning, rebuilding, and reaching for Mars. The immediate future for the Starship program is clear. A thorough investigation into the anomaly will occur. Teams will pore over all the collected data. They must identify the root cause of the failure. This detailed analysis is the primary focus now. Understanding exactly what happened is paramount. Only then can effective corrections be made. Following the investigation, the next steps involve action. Engineers will implement design changes. Production of new Starship prototypes continues at Starbase. More ground tests will likely be conducted. These tests ensure new components work as expected. Then SpaceX will prepare for the next flight test. The cycle of improvement will continue. Each attempt gets them closer. The road to Mars remains long and challenging. Many more successful test flights are needed. Starship must first reach orbit reliably. Then it must demonstrate controlled re-entry and landing. This includes both the booster and the ship. Orbital refueling is another critical technology. This allows Starship to carry enough propellant for Mars. Each step is a major milestone. Space exploration is inherently difficult. Failure is often a teacher, not an end. SpaceX has demonstrated remarkable resilience in the past. They learn from issues and iterate quickly. The dream of humans walking on Mars is a powerful motivator. It fuels the efforts of thousands of engineers. Humanity's future among the stars depends on such perseverance. The journey continues.